Okay, let's try this question, question 12. All right. So what are the functional groups here? There's a ketone here. All right, a ketone here. In fact, this is an this one actually is an ester. All right, it's an ester over here. This is a secondary alcohol, and this is a secondary alcohol. All right, and actually this is an aldehyde. Okay, this is aldehyde. Okay, so if I look at B and W for A, B, C, and D. Okay, let's look at for A, iodine and aqueous sodium hydroxide. Okay, it's positive for this structure. It's also positive for this structure. So which means for V and W, all right, is A is positive for both, so it cannot be used to distinguish. Okay, 2,4-DMPH is also positive for your ketone and for your aldehyde, which means it's positive for both. You get orange PPT, so you can distinguish. Okay, this is very, very tricky, but I have to teach you something about hydrolysis of ester. If actually there's acid, all right, this question should say it's hot acid actually, all right. Anyway, okay, so if there's acid and there's heat, all right, what will happen is, in fact, the ester can actually undergo acid hydrolysis, right? The ester can actually undergo acid hydrolysis. So if you have not learned this, let me just run through very quickly. So if you have an ester like this, right, or esters, right, this. Okay, so this is your ester linkage. Okay, I'm gonna just highlight. Okay, so take note, this is your ester linkage. All right. So esters will undergo acid hydrolysis or base hydrolysis. So hydrolysis is probably like you add an acid hydrolysis, you add acid aqueous, all right, aqueous, and heat, all right, and heat. Okay. So what really happens is this. What's actually really happening is this. So water, okay, water is over here. So hydrolysis must always involve water. So this is delta minus, and then the delta plus. So the water will attack this carbon, all right, and electrons will go to this O, okay, and this bond will totally break. So you break the ester linkage. Okay, so what will be formed? You're gonna get CH2 here, O, all right, but this bond will also break. Okay, so the H will actually go to the O, you get OH, and then on the other side you get C double bond O, CH3, and OH. Okay. So you always, when you hydrolyze an ester, you get a carboxylic acid and an alcohol. It's like what are reagents when you form ester? You use carboxylic acid alcohol. When you hydrolyze it with acid, aqueous acid, you get carboxylic acid alcohol. And if you look at this structure here, this one turns out to be a primary alcohol. All right. So this primary alcohol can be oxidized by the potassium dichromate, which means the orange will turn green. So there will be a positive reaction here. Okay, and if you look at for W, both are secondary alcohol, which means both can also be oxidized by potassium dichromate from ketone, and the dichromate will change from orange to green. So this should be correct. Okay, the answer for last one is actually, they put silver nitrate and aqueous ammonia, is actually Tollens. It's actually Tollens reagent. So Tollens reagent is only positive for aldehyde. So this is positive and it's negative for this. So the answer has to be D. Okay, so it's a bit tricky for question 12.